What's up everybody, welcome back to Electronics Wheel, and it's the first video I'm going to post about my project. This is my project. It's the Arduino resistance meter. It took me a couple of while to program it because we need to convert the analog and the analog type of the pin to the digital type of the pin. So I took a while to do that. I'm finally done with my project. So here is what's going on inside the project. We have the Arduino Uno over here. So the Arduino Uno in particular is a pretty good board. It has I2C, it has SPI. It's all good board, actually good for developers. But the problem is that you can't do multi-threading on it. So use a Raspberry Pi or something to do a multi-threading. So I usually run small projects like program which does not involve multi-threading. So it's pretty good for developers, and this was the first board I had for my career in this field of technology. Then we have our 10 kilo ohms potentiometer to adjust the contrast of this LCD display. We do have a LCD display over here that is a 16 pin, and please note that I'm not using an I2C to communicate to this LCD through Arduino. So in fact I'm using all the pins used except for the data pins. So it's a pretty cool project, and when you have something like this, it's good for all types of, like, you don't need to buy an additional multimeter, and it's accurate. I think so this is accurate, it's not accurate some for like 1% or something. So it's pretty good, but so welcome back again, and so we here have our code, and this is a code for our Arduino resistance meter. So I'm going to explain briefly about this code I made. So here we do have our we are including our liquid crystal library for our LCD display, and we are defining all our LCD display pins. The pins are 8, 9, 10, 11, 12, and 13. So we assign an integer, and here in the third line we assign an integer for the analog pin 3, that will be our measuring our resistance for the known value also, as well as the unknown value also. And we assign a raw pin, that's 0. And here we do have initial integer voltage input, that's 5 volt. That's mainly 5 volt because we are only giving 5 volt power supply from the Arduino board. If we put 3.3 volt also, it will run fine, but as we have our LCD display, and also I do recommend putting 5 volt over here, or just simply 5. So we give our float voltage drop. So why I have put the float pin is because we need a decimal point in our result. So I don't want anything like integer. If you put integer, it will show the correct number. That's if it's like 2038, it will just show 2038, or it doesn't shows any decimal. But if you put float pin, it will surely do a shortly it will surely have a integer assigned, I mean a decimal assigned in your results. So these are all this. So there's a void setup which will run our code first. That's the LCD print resistance meter. This process is where the our system will boot up, and we do have serial begin over here, 99,600 baud rate. We do have LCD begin for our LCD display, that's 16, first of 16 into 2, and we do have print resistance meter at for 8 seconds. Here we have our code which will measure the resistance of the unknown value, and it will give the value of the value. It will assign the value of the non-resistor also. We do have a raw pin over here. It's analog read, and analog read, it will read from the analog pin that is having information. We do have some of the mathematical calculations over here, which I'm not very good at. I got help from some of my friends for this code. And here we have serial print for this voltage drop. And one more thing, if you have this code running and if you don't want an LCD display, it's fine. Just remove this LCD print, LCD set cursor and some of the void setup. You remove LCD begin and LCD print and delay and clear also. And you can see that if you open the serial monitor, sorry, I didn't actually connect the board. So if you connect the board and if you open the serial monitor, you can definitely see the voltage drop and the unknown value resistor over there. And we do calculate this voltage drop and the unknown value the resistance of the unknown resistor for like 10 seconds. Every 10 seconds it just calculates based on the analog input reads, and it's pretty much it. So let's get going and see how it works.
Alright, so let's go ahead and see how this works. So, I do have my non-resistor, that's a 100 ohms resistor. Let me zoom in. So, there are two types of resistors. For this resistance meter, that's the non-resistor, that's this one, this 100 ohm resistor, and I do have a 5 band 2.2 or 2.2 kilo ohms resistor. So I was searching for a 4 band or thing, but I didn't get, so I continued to use this 5 band. And I do have a and keep in mind, this project is always based on a non-value resistor, and so this is the non-value resistor and this is the unknown value resistor. I do have my ground plugged into one end of the non-value resistor. I do have my analog pin from the Arduino to the 100 ohm resistor and the 2.2 ohm resistor where it meets, and both are in parallel. So the analog pin can communicate in parallel to both of the resistors, and we have a 5 volt resistor that is connected to the end of the 2.2 kilo ohms resistor. So this project is all for measuring resistance for the resistor which we don't know. So in particular, we need a non-value resistor and the resistor which we want to find the value of. So let's plug it in and see how it works. So we do have the Arduino there. Let's connect and see. Alright, so it's booting up, so you can see over here. So it shows a resistance meter is just booting up. It will take a couple of while to load. Oh yeah, so now it's showing the value. So it shows the the voltage drop across the unknown value resistor and the the value of the unknown value resistor. So this is the value. It just shows like this. I need to put voltage drop and R2 over here. If you want, you can adjust your contrast for this LCD. I don't need to say this because you guys all know who are watching this video, and that's pretty much it. So it just shows. And if you want to test another resistor, I do have a 2.2 ohm resistor fit in here. That's the blue one. And if you want any other resistors to find the resistance, you can just plug it in, or if you want to test if it works, it works. So this shows 2338.10 kilo ohms, which means somewhere near 2.2, because it has the tolerance band. So we can't actually say the value is this much because it has a tolerance. So the value is somewhere near to 2.2 kilo ohms. So pretty much it. So thanks for watching. If you like, give a thumbs up and hit the subscribe button, and stay tuned for more videos and more project electronics wheel.